Well, I hope you attempted to do the homework and got some answers, because I'm going to go over the solutions here. So the first thing we want to do in number one is we want to sketch the graphs of the first and second derivatives. So I'm going to start with drawing the x and y axis. So here's my x and here's my y. And then what I'm going to do on the left-hand side is find when the derivative is 0. So now the derivative is 0 when you have this 0 slope. So I have 1 point, 2, and 3. So the rate of change is 0 at these points. So over here on the left, I'll put these points on my derivative, the graph of my derivative. So the heights are 0. And so remember, the rate of change is 0, and when I say rate of change, you say derivative, and so the derivatives have to have 0 heights too. And in addition, I'm going to label this. Okay, so this is my function f of x. And then, of course, this is going to be my f prime of x. And so the second thing I want to figure out is when the rates change, when the derivative is positive or negative. So it's increasing here, so the derivative must be positive. It's decreasing there, so the derivative is negative. And the derivative goes positive again, and then the derivative goes negative, because it's decreasing. And over here, then I'll say, okay, to the left of this point, the derivative is positive. Between these 2 points, the derivative is negative. To the right of these 2 points, it's positive. And then to the right of this last point, it's negative. And I'll simply try to connect the dots in a nice, continuous manner. So let's see. It comes from here and it goes down. Then it must come back up. Then it comes up, and then it comes down again. And then it goes down. So something like that. So that's my first derivative. And then to find my second derivative, the graph of my second derivative, f double prime of x, I basically do the same thing, but I kind of just ignore this graph and use this graph. And so I'm going to, again, draw my x and y axis. So here's my x, and there's my y. And I want to figure out when is my slope, my rate of change, my derivative, 0. And so I have derivative 0 here, and I have derivative 0 here. So I'm basically doing the same thing, because the second derivative is really just the derivative of the first. So the same sort of way I did it before should still work. And I get, means this is 0, the rate of change here is 0, and the rate of change over here is 0. So the second derivative is 0 at these 2 points. And then I want to figure out if it's positive or negative. So I'm going to do this in, let's do it in red again, because I don't want to get confused with that green. So it's decreasing, so negative. It's increasing, so the derivative of the derivative is positive. And it's decreasing, so again, the rate of change is negative. So the second derivative is negative. And then I can plot that over here, so it goes negative. Then it goes positive. And then it goes negative again. And so if I had to draw this one, I'd connect the dots as well as I can, so it would go up. Then it has to turn around and come down and go through that dot and get done that way. I guess I should put arrows on here. And so there's the graph of my first derivative, and then my second derivative, which is simply a derivative of a derivative. The second problem entails finding the first and second derivative using the definition. So hopefully, by now, you have the definition memorized. If not, keep writing it down. And I want to find f prime of x using the definition. So it's equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And this is just the same type of problem we had on the last assignment. So I just do what it says. So this is equal to the limit as h goes to 0. And remember, h is simply a rule. And so here's the rule. And it says whatever's here, put down here. And so now I have this here, so I'm going to put it down in the bottom. Right, so I have 1 over x plus h, that's f of x plus h, minus f of x, which is 1 over x. Oops, I made a mistake there, didn't I? Let's fix this. So it's not 1 over x plus h. There's a 2 and a 3 there. So there's a 2 on top divided by 3 times. That's 3 times the whole thing, right? Whatever's in red, 3 times the whole thing. Let's call it red, right? 3 times the whole thing in red. And then this is a 2, and there's a 3 down here. Now this is all divided by h. And I'm going to redo that 3 because it looks terrible. So that's a 3. So hopefully you see how that lines up. Now I have to get a common denominator. To get a common denominator, I realize that I have an x over here, and I don't have an x over here, so I'm going to put one. I'll put one right here. So there's my x. If I put an x on bottom, I better put an x on top so I don't change the expression. And then over here, this is x plus, needs an x plus h, because I have an x plus h over here, so I need one over there. And I'm going to put it on the top also, so I don't change that expression, that fraction. So this is still 2 over 3x, and this is still 2 over 3 times the quantity x plus h. But now that I have a common denominator, I can do this subtraction. So I have the limit as h goes to 0 of 2x minus a 2 all times x plus h. And I copy down the common denominator, which is 3x all times an x plus h. And I'll divide it by an h. And so this is going to equal, and I can do this little algebra on top right here. So this is 2x minus 2x minus 2h. So don't forget to distribute that minus sign through. And so the 2x's are going to cancel. And this is going to equal then the limit as h goes to 0 of negative 2h all divided by this 3x times x plus h, and then that's all divided by h. All right, so if you think you can plug in h equals 0, try, but if you try to do this, you're going to get 0 over 0, so there's still more for us to do. And the next step is, since we're dividing by a fraction, h over 1, I can simplify this by multiplying by the reciprocal. So the limit as h goes to 0 of negative 2h all divided by 3x times the quantity x plus h, then divided by h over 1, it's the same as multiplying by 1 over h. And this is nice because then we see that these h's cancel. I'm going to go back to black here. And so what we get is the limit as h goes to 0 of negative 2 over 3x all times x plus h. Now when we plug in h equals 0, we're going to get an answer. And the reason we're going to get an answer is because we fixed or got rid of this indeterminate form because we crossed off h's. That's our 0 over 0. And now when we plug in 0, you're going to get an actual answer out that's not indeterminate. So you have negative 2 divided by 3 times x all times x plus 0. Right, remember, we're plugging in h equals 0, not x equals 0. And so this is equal to a negative 2 divided by 3x squared. And so that's the first derivative. Right, so this part is done. And now we need to find the second derivative using the definition. So hopefully you kind of see, to find the second derivative, the first thing you have to do is find the first. And then the second derivative has basically the same definition as the first, except instead of using the function f of x, we're going to use f prime of x. So this is the limit as h goes to 0 of f prime of x, f prime of x plus h minus f prime of x all divided by h. because you can think of the second derivative as simply the rate of change of the first derivative. So it basically uses the same definition. The only difference between these two is down here. The second derivative uses f prime of x, right, instead of, f of x. It's the only difference, right? So we have f prime instead of f. Now to compute this derivative, right, to compute the second derivative, we're going to have to use the first. So I do what it says. It's the limit as h goes to 0. And now f prime of x, remember, is right here. And it says wherever you see an x, right, you just put it down here and square it. So whatever's inside here, put it down on the bottom and square it. So here's what's inside there. And so I'm going to put it on the bottom, and I'm going to square it. And then on top I have a -2, and then on the bottom I have a 3. So f prime of x plus h is equal to -2 divided by 3 times the quantity x plus h squared, minus f prime of x, which is the minus a -2 divided by 3x squared, and then all divided by h. Now some nice things are going to happen right at first. I know a negative and negative is a positive, so I can change this to a plus. And then I need to get a common denominator, so I have an x squared on the right, so I'm going to need an x squared right here. So I'll put x squared here. If I put an x squared on the right, on the bottom, I better put it on the top. And then I have an x plus h quantity squared on the bottom on this side, on the left-hand side. So I better put an x plus h quantity squared here. So I get a common denominator, extend this vinculum over, and so I have x plus h squared on the top too, so I don't change the fraction. So this is still 2 over 3x squared, and you can see here with the colors it's still -2 over 3 x plus h quantity squared. And now what happens is I can combine the fractions, so I get the limit as h goes to 0 of -2x squared plus 2 times x plus h quantity squared, then all divided by 3x squared x plus h quantity squared, and then that's all divided by h. Alright, so I have some simplification to do on the top here, so let's do that. Let's do it right here. So I have negative 2x squared plus, and then if I multiply out the x plus h squared, I'm going to get x squared plus 2xh plus h squared, so I'm going to have 2x squared plus 4xh plus 2h squared. This is a 4. And so what I'm going to get is this limit is equal to the limit as h goes to 0, and the 2x squareds are going to cancel, and I have left over a 4xh on top plus a 2h squared, all divided by 3x squared x plus h squared, and then this is all divided by h. If you want to try to plug in h equals 0, you can, but you'll see you still get this indeterminate form out, 0 over 0. And so now the trick is to multiply by the reciprocal because you're dividing by h. So this is going to equal the limit as h goes to 0 of 4xh plus 2h squared, all divided by this bottom piece, 3x squared x plus h quantity squared times a 1 over h. And then you're going to get some cancellation. All right, what's going to cancel? Well, if you think about this, this top part can be simplified. You can factor out this h. So you have h times 4x plus a 2h. And so h times this is that. And so think about this when you see, you can factor out an h. And then the h's will cancel. I have h on top and h on bottom. And so this is going to equal then, this is going to equal the limit as h goes to 0 of 4x plus 2h, all divided by 3x squared times x plus h, quantity squared. And now if I let h equal 0, I'm going to get an actual answer. So I'm going to let h equal 0. And so I get the limit. Oops, not the limit. All right, I'm going to plug in h equals 0 so I can drop off the limit. And I get 4x plus 2 times 0, all divided by 3x squared times x plus 0, quantity squared. And so on top, I just have a 4x, because 2 times 0 is 0. And on the bottom, I have a 2x squared times another x squared, so I'm going to get 3x to the 4th. And then an x is going to cancel on top with 1 on bottom, so I get 4 over 3 x cubed. And that's my answer for the second derivative.